Julia Martínez. Thank you very much. Muchas gracias. Buenos días a todos. Thank you. I would like to introduce a specific case, some of the questions that Abel brought up. This case is the coastal lake of Mar Menor and its basin. It's a drainage basin. It's in the field of Cartagena. Very briefly, I will introduce you to some key elements of the context of this area. It is the biggest coastal lake of the whole of the Western Mediterranean, and it is also very special, not only because it has a great ecological and biodiverse value, and it's been recognized at a national level, at an European level, and even at an international level, but also because it's one of the few great Mediterranean coastal lakes that have reached the 21st century with oligotrophic waters. So most of the cases which are similar are devoted, for example, to the production of water culture, because their waters were very rich in nutrients, and we didn't have many other left with waters which were transparent, incredibly transparent, and oligotrophic. There you have an image of what I was telling you about. And as I was telling you, there are many values associated to biodiversity with very singular and very peculiar species which are restricted or endemic, and some natural wetlands like the ones that you see here, with some protection figures which are very important. In the basin of this Mar Menor, in the last few decades, this irrigation agriculture has been developing. It's been increasing in a very evident way in the last few decades, in a very steep way, with trees and an important percentage of greenhouses. And approximately 10-15 years after the sustainable growth of this irrigation, we started to see some symptoms of an excessive increase of phytoplankton, what we call eutrophication, derived from a higher enrichment with the nutrients, nitrogen and phosphorus. These first symptoms appeared in mid-90s with massive explosions of jellyfish, which are not autochthonous here. There was some summer at the end of the 90s with more than 40 million jellyfish peaks in the lagoon, and we also had a green waters episode, but they were very much localized in a controlled space, or in a time period, in a time lapse of just a few days. In spite of that, from 2000, the scientific community and other citizenship organizations, they were alerting on the risk of having an ecological change in Mar Menor if this entrance of nutrients continued, from the basin. But Mar Menor seemed to be very resilient and very strong, and it could metabolize all those nutrients, but there is a limit to anything. And in the year 2016, what happened is that there was a acute emergency, acute eutrophic crisis, so that the whole of this lagoon, you can see here concentrations in 2016 of chlorophyll and phytoplankton within the place, and it had already started to contaminate the rest of the Mediterranean. The water transparency disappeared, and it was substituted by a green water mass, which generated the ecological collapse of this place, because oxygen disappeared. There was a great decomposition of organic matter, and from then the bottom and some of the fauna communities disappeared, and it has also putting at risk some species. We have the best populations of those species here. To say, for example, Pinna nobilis, which is at severe risk of extinction at global level, because there is not much left in the best reservoirs, and that was Mar Menor. What are the consequences? They go beyond the ecological part in the sector of tourism. Also, the image of Mar Menor at an international and national level, it's been having social consequences, political and social conflicts, like you can see here. Some of the demonstrations, and also some legal actions being taken in Spain. There's also in the European Commission and international Barcelona Convention and Ramsar Convention. So our question is water and nutrients efficiency enough to avoid this? Could we have avoided this with an efficient use of water and nutrients? Well, it's a very relevant question in the case of Campo de Cartagena, because we're talking about farming which is very modern, where there is no irrigation by gravity. There's a very intensive farming which is very technical and very much supported by research, innovation and development, with fertigation systems virtually generalized, with quality control systems from great European distributors that determine the scale of each plot and each farm, what to grow and how to do it. And where since the year 2001 we count on the declaration of a vulnerable area by nitrates, with action programs which have a good practices code approved, with fertigation control, and there is a specific program for the promotion of integrated agriculture. There is intelligent minimum fertigation, and where there is a very common development and intelligence and development activity. So, even if we have been innovating a lot in this area, what we have is an ecological collapse due to the massive entrance of nutrients coming from agricultural fertilizers. How can that happen? Why, in spite of that efficiency and innovation, why has that increased? Well, because there has been a significant increase of irrigation. All those blue colors, the different shades of blue, are different kinds of irrigated crops. All of these modern intensive crops, when it comes to technology. This is an image in 1988. This is an image in 2009. Quite any kind of gaining when containing the leaching of nutrients is is blocked by the increase of the irrigation in the whole of the Campo de Cartagena. All of that surface generates the export of nutrients on the surface and subsurface, and other flows that is actually washing out the whole of the basin and is introducing all those agricultural nutrients in the lagoon. So, all the flows are overloaded with nitrogen. For example, surface flows have an average of 150 to 250 milligrams per liter. Also, substrate water and underground water can have more than 85%, and there you have some estimates on the increase of the leaching of nutrients to the lagoon. So this indicates that it is not enough to be efficient to control or prevent diffuse pollution. That, in spite of the fact that we have this cutting-edge technology, what we have in 2016 and 2017 was these kind of images. So we cannot just have think about plots in an isolated way. We have to look at the whole of the system, all cumulative and synergic effects, because at the end of the day, the lagoon doesn't care about the hectare-related yield. It just cares about the total amount that it's receiving every year. So, as a conclusion, the efficiency in the Campo de Cartagena and Mar Menor lagoon has been proven not to be enough. And these are some of the conclusions that we can reach. There is a clear problem in which intensive irrigation is linked to diffuse pollution, nutrients. That's what I talked about in Cartagena, but Mar Menor lagoon is receiving, there are scientific studies published that show that it's receiving more than 70 different substances derived from pesticides and herbicides, and this cannot be only controlled by efficiency policies. We also have to think about the total surface, total figures and total values. We also need to have this comprehensive view and systemic view of what's happening, because we need to examine intensive farming in the right way. And this assessment should be judged by the state of the ecosystems, of the Mar Menor and of the rivers, the state of the landscape, aquifers, soil, biodiversity, and nature itself. So here we find a dichotomy between whether focus on effectiveness, see if we are reaching the environmental objectives or not, and efficiency. So relative values, per hectare, per liter, and just unitary values or at the level of plot. But in the case of Mar Menor, we're saying that this plot scale or farm scale efficiency is not enough to guarantee that this diffuse pollution will be controlled and that we are going to avoid ecosystem damage. That is totally insufficient. And finally, this principle of whoever pollutes will pay for it, in general, that's not being applied in Spain to farming, and we should start implementing measures, and there we have to talk to the regulation makers. In fact, in Portugal, they are starting to apply the principle of whoever pollutes will pay for it. That's very interesting. We have to start applying that with this general outlook, thinking about the system, not only in relation to, not only at farm scale, but also in general. These are good practices the Commission is saying already that it's not enough. So we have to start applying the principle whoever pollutes pays, not at a farm scale, or at least not exclusively, but also at a whole system scale, because we are having more water in the rivers, better quality water. So with that, we will be avoiding these other pollution processes like what's happened in Mar Menor Lagoon, or what could happen in other rivers and aquifers. And with this, I finish. Thank you.